Hello. This week we are focusing a lot on proving identities in our trig portion of the class. So I want to do a couple more proving the identities. A couple of recommendations that I have when you are proving the identities is I would have a sheet similar to what I have right here with the reciprocal, the quotient, Pythagorean, and the odd and the even functions. We haven't talked about this yet. We certainly will. So I would have this kind of close by. After I do this identity, I'm going to do another one with sum and difference. And so I'll have another sheet. I've posted a couple of different trig sheets, different things that for the notes that you want to have out, just so that you have those close by. And it's not, you will start learning and the pattern and the justification and the reasoning behind all these, the more that you use them. So I would have this close by. So what we are doing right here is we are proving the identity that the cosecant of negative x minus the sine of negative x is equal to the cosecant of x. Oh, I'm sorry, I wrote that down wrong. Let me fix this before we get started. This is the negative cosine of x times the cotangent of x. So what we're trying to do is we are trying to go from this statement right here to this statement right here. And we are going to use these identities in order to do that. That's what we're doing right here. So I'm going to get started, and we have got to write down the reasoning for why we are able to do what we are able to do. So the very first thing that I'm going to do is I am going to take the cosecant of negative x, and I am going to find out how to rewrite that based on my odd and even function identities, and they are right here. This is what I'm going to focus on. Now, when I took my screenshot, I kind of messed it up, so I am looking right here. This is what I'm looking at. The cosecant of theta, or the cosecant of negative theta, is negative cosecant of theta. So I can rewrite that. Apparently, this morning I'm having trouble writing my functions. There we go. Cosecant of negative theta is equal to the negative cosecant of theta. So that is what I'm going to write down first. So I've got cosecant of negative x is the same thing as negative cosecant of x. Okay, now I am subtracting the sine of negative x. So I am going to look and see what the sine of negative x is, and it is the negative sine of x. So I am going to rewrite this as the sine of x. And the reason that I'm writing it, so what happens here is I've got the negative sine of negative x. Then when I take this property right here, I've got the sine of negative theta is equal to the negative sine of theta. So I am going to make this negative sine of x, okay? But right here, I've got minus and minus, so that becomes plus. So what I'm doing right here is I've then got negative cosecant of x plus sine of x. And the reason, and I did do some algebra in there, but the reason for this step right here is my odd and even function identity. Okay, so that is how I justify that step. Now, I would call this minus and negative an algebra step, but you can include it or not include it, either one. Okay, now what I'm going to do next is I am going to look at this negative cosecant of x, and I am going to look at my reciprocal properties. So I have cosecant of theta is the same thing as 1 over the sine of theta. Now I still have my negative, so I'm going to keep my negative, but I'm going to rewrite that as negative 1 over the sine of x. And then I have plus sine of x. And the reason that I'm able to do this step is the reciprocal identity. Reciprocal identity. That's what allows that to happen. Now that I've got kind of a sine of x and a sine of x, and I'm adding, I'm starting to think, well, what is it that I want to do? What is it that I want to try to figure out? And I'm headed to trying to get the negative cosine of x and the cotangent of x. And part of this at this point is we are doing some trial and error, and don't be scared to do that trial and error. Sometimes that happens, and sometimes we're not going to make it to where we want to make it, and so we're going to have to kind of go back and we're going to start over. But you've got to do the trial and error. You've got to think about, well, will a reciprocal help me? Will the odd and even function help me? Will the Pythagorean identity help me? So there's not really a pattern that you follow. You are looking at these identities, and you are looking at the relationship between the functions and trying to prove that these are the same. So usually I'm always, you look at the odd and even, and then I kind of go back to my reciprocal functions to see if I can kind of get things in some commonalities. And so that's what I've done here. I'm like, okay, well, now I've got both of these are the sine of x, and I know that if I can get something squared, then I can start looking at the Pythagorean identities. So since these are both under the sine of x, I am gonna go ahead and put this one under 1, and I'm gonna make a common denominator and see if that helps me. And it does help me once I get that. Now I'm gonna kind of do some work off here to the side. So what I'm doing is I am finding a common denominator. So I have -1 over sine of x, and I want to be able to combine that. So I've got to make this +1 the sine of x. So I have made this a common denominator. So what happens now is I've got to multiply sine of x over sine of x right here to get that common denominator. So when I do have that, I have sine squared of x. And once I get that sine squared, that's when I'm thinking, okay, maybe the Pythagorean properties are going to, or their identities are going to be helpful here. So now, because I have done that right there, I am able to say that -1 plus sine squared of x over sine of x. And I definitely want to start thinking Pythagorean at this point because I've got something squared. So I'm going to go back and I'm going to look at this right here. So I'm like, okay, so I'm definitely going to end up with a sine squared. I've got a sine squared. So if I pull that sine squared over, so I have sine squared of theta plus cosine squared of theta equals 1. So I'm going to subtract that sine squared of theta from both sides. So I end up with cosine squared of theta equals 1 minus sine squared of theta. And I'm thinking, this might be helpful. This might be helpful. So I go back and I look over here, and I've got -1 plus sine squared of x. And so that's not exactly what I want. But I can factor out a -1. So if I factor out a -1 here, so if I have -1, then I'm going to end up with 1 minus sine squared of x. And that actually gets me where I want to be. Okay, so what happens here, and so that's algebra 2. All I did was I factored out a -1, and that's algebra. Okay, so I'm going to put algebra right here. Okay, so I factored out a -1. So I can take this right here, my 1 minus sine squared x, and I can replace it with the cosine squared. Okay, so I am definitely running out of room. So I am going to erase, go back up here to my, I want to keep my original for sure. And so I have used the Pythagorean identities. That's what I've used now, Pythagorean identities. And I have -1 times the cosine squared of x over sine of x. Okay? Okay. So we're headed in the right direction because I've got a negative cosine x right here. So we kind of should start seeing things kind of go together here. Now, so I've got a -1 times cosine squared of x over sine of x. If I go here and I look at my quotient property, the cotangent of theta is cosine of theta over sine of theta. And this is going to be super helpful because that's exactly what I need. Okay, so if I write this out, cosine squared of x is the same thing, and this is just algebra, of cosine x times cosine x. That's what that is. Okay, and that is over sine of x. So what I can do is I can take my cosine of x over my sine of x, and I can replace it with cotangent. Okay, so I will have -1 times cotangent of x times cosine of x. Okay, and what I have done here, what I have used here, is the quotient identity. Quotient identity. And from this, I just do a little bit of rewriting, and I end up with negative cosine of x times cotangent x. And I'm there, and that's what we want. And so I know that these are a little bit of trial and error. I completely and totally understand that. And it just takes practice. Just takes practice. Okay. Okay, here is another identity that we are being asked to prove. So what we are being asked to prove here is that the cosine of x minus y times the sine of x minus the sine of x minus y times the cosine of x will simplify and give us sine of y. Okay, so again, what I would encourage you to have in front of you are the sum and difference formulas, which is what we have right here. I've got all that down. And I would encourage you to have the reciprocal identities and all of this in front of you.